A couple of announcements. So I believe last week I said makeup work was due last Friday. Um, I was wrong. And so the makeup work for 1314 will be due this Friday. So I will still accept it if you haven't turned it in yet. Um, Today we're going to finish up 4.4, which is our last section on systems, solving systems of equations. And this part of this section will focus on word problems and solving word problems that you can write a system of equations for and then solve them. So kind of the schedule for what's going to happen. Um, we will have um, the 4-4 day 2 note check and homework. Try to get that in as soon as possible. By Thursday morning would be great. We will then have a 4-1 through 4-4 review and a 4-1 through 4-4 quiz. And again, if you can get that done over the weekend, then you'll be in good shape. You could possibly even get it done Friday during your regular class time. The other thing that's not on our agenda that I want to talk about is registration. Registration is going to happen within the next couple of weeks. You will be getting information in your civics classes, I believe. So for math, you need to pass 2 trimesters in order to go to the next math course. So if you passed trimester 1 and are doing well in trimester 2, you'll be in good shape. And the course you want to register for is geometry. Now, if you're finding intermediate algebra to be very easy, you may want to consider honors geometry rather than regular geometry. Generally, we say in order to go from regular to honors, you need to have straight A's in the previous course. So that's what we would be looking at. If you are wanting to take calculus in high school, what you would need to do is take geometry and algebra 3 next year, and then you would take honors pre-calculus your junior year, and you could take calculus in your senior year. So things to think about. If you have questions, when we break into our breakout rooms, that would be a great time to ask. If you want to make sure that you don't forget your question, you could type it into the chat, and I can jot it down and answer it if you want. When we get to those breakout rooms. All right. So let's see. So systems of equations, word problems today. So we're going to use systems of equations to solve some real world type problems. And the problems generally break down into one of two or three categories. So I think once we see a couple of examples, it's really easy to say, okay, this is this type of problem, and it makes it a little bit easier. So basically, we can think about this as a 5-step process. Once you read the problem, you're going to label your variables, or define your variables, sometimes it's called, to represent the quantities that you are solving for. The second step, in this case, we're going to write two equations using the variables that we defined in step 1. Then we need to pick a method to solve the system. And I'll be honest, there'll be one method that is used more often than any of the others. You'll see that when we get to our examples. Step 4, solve your system. So whichever method you chose in step 3, you're going to use that to come up with your solutions. And then step 5, label your answer according to the problem. So if you were finding something with money, labeling it with a $sign, or however you're labeling that money. If you were finding, I don't know, the number of tickets sold, you'd label tickets or whatever. But having those labels are important, as opposed to previous systems where it was just the ordered pair for the solution. All right. And I am going to mark up the question quite a bit. I have kind of developed I didn't develop it. I stole someone else's method for marking up word problems. And it really does kind of tie in for those of you that are Avid students, or that have used Avid in the middle school. It does kind of follow some of the Avid strategies. So if we look at the first example, Brenda and Adam are selling cheesecakes for a school fundraiser. Customers can buy pecan cheesecakes and chocolate marble cheesecakes. Brenda sold 13 pecan cheesecakes and 9 chocolate marble cheesecake for a total of $305. Adam sold 12 pecan cheesecakes and 9 chocolate marble cheesecakes for a total of $294. Find the cost of each cheesecake. I think there were some typos in there, but that's okay. So the method that I use is called cubes. And the C for cubes, it stands for circle the numbers. So I just go through and I circle any of the numbers that I find. Now, you do want to be careful, because sometimes in a word problem, the number might be typed out. So, but that's the way that I start. So circle the numbers. The U is for underline the question, or underline what you're trying to find. So that's what I'm trying to find. The B. box any keywords. So, and when it says keywords, I mean keywords for the problem itself, for the mathematics that we're doing. It's not, selling, it wouldn't be a keyword. But in this case, I think pecan cheesecake and chocolate marble cheesecake might be a keyword. Total might be another keyword. All right. Then comes the E. And for me, the E stands for equations. So now I want to write my equations. I'm trying to find the cost for each of the cheesecakes. So that's what my variables are going to define. So I like to be pretty deliberate about my variables. You could use X and Y. In this case, I would probably use P for the cost of pecan cheesecake and C for the cost of chocolate marble cheesecake. My equations then are going to somehow relate the cost of those to the information I have in my problem. And it's pretty nice because we have two different people selling cheesecakes. So one of my equations will relate to Brenda and the other equation will relate to Adam. So I know Brenda sold 13 pecan cheesecakes and 9 chocolate marble cheesecakes for a total of $305. Adam sold 12 pecan cheesecakes and 9 chocolate marble cheesecakes for a total of $294. All right. Now we need to determine a method to solve this system. So if you remember, we have talked about 3 different methods: graphing, substitution, and elimination. So which method would work for solving this system? All right, and the chat is blowing up. Yeah, I like it. I like it. I think elimination would work the best. And the reason I think elimination would work the best, I don't have both equations in a y equals form, or in this case, a p equals form or a c equals form. And I don't have one of the variables by itself. So elimination is going to work the best. To use elimination, the first thing I look at, do I have opposite coefficients for either of my variables? And in this case, I do not. So then I look, do I have the same coefficients? And the C is the same for both. So what I can do, when they're the same, I can multiply one of my equations by -1. I am going to choose to multiply the bottom equation. So my top equation stays the way it is. My bottom equation, I just take the opposite of everything that I have there. And now I add those together. Excuse me. So I had 13p plus a negative 12p, or 13p minus 12p is just 1p. 9c minus 9c, that's 0. The c is eliminated. Excuse me. 305 plus negative 294. 11. And now I already know then the cost for a pecan cheesecake is $11. It just so happened that when I eliminated the C, it just left me with P as my variable and a coefficient of 1. Now I need to find the cost of the chocolate marble cheesecake. So I'm going to take that 11 and plug it into one of my two equations. I'm going to choose the second equation. So I'm going to get 12 times 11 plus 9c equals 294. 12 times 11 is 132. And 294 minus 132 is 162. Dividing by 9, we get C equals 18. So now I want to label my answers and answer my question. So in this case, I would say the pecan cheesecake costs $11, and the chocolate marble cheesecake costs $18. And that's the problem, or that's the solution. So very common, one common category of word problems for systems is total sales. In this case, it was cheesecakes sold by two different people. We'll see another example that deals with sales a little bit differently with our next example. Any questions on the first example? All right, second example. The Simley Theater is putting on a winter play. Adult tickets are $8 and student tickets are $4. They sell a total of 350 tickets. They collect a total of $2,000 from ticket sales. How many adult and students attended the play? So again, using that cubes idea, circle the numbers. Underline the question. Box any keywords. I think that's it. Anyone see any other keywords maybe in the question? All right, then we need to define our variable, write our equations. And so to write our equations, we're going to define our variables. Pretty easy in this case, I think. One variable will represent the number of adults that went to the play. And one variable will be for the number of students. So if I go A is the number of adult tickets. And even though I don't like using it, I'm going to use the letter S. I generally don't like S for a variable because it looks too much like a 5. So I'm going to try to be very deliberate in the way I write my S. All right, so I've got my two variables. Now I need to write some equations. So unlike the last example, this time we're not comparing the number of things one person sold and the number of things a second person sold. But what we're comparing, or what we're looking at, are two different totals. So if I take the number of adult tickets plus the number of student tickets, I know it has to equal 350. So adult tickets, which is A, student tickets, which is S, has to equal 350. The other total that I'm looking at is the amount of money from ticket sales. So for every adult ticket, I get $8. So I get 8 times A for adult tickets. And every student ticket is $4. So I get 4 times S for the student tickets. And that has to equal 2,000. All right. Whew. Which method am I going to use to solve this system? Substitution, graphing, elimination. What do we think? And don't tell me it's Wednesday. We don't think on Wednesday, because that's not true. All right, so we've got a couple of thoughts here. One for elimination, one for substitution. And you could do either. You could do either. In order to do substitution, I would probably work with this first equation and solve it for either A or S. So there would be a little bit of work to do ahead of time. And you could, looking at it, I would look at it and think elimination. Again, because in both equations, both of my variables are on the left-hand side of the equation. But substitution could work. It just takes a little bit of doing. If I use elimination, I would want to, again, look for opposite coefficients, and I don't have coefficients that are exactly opposite. So then I look for coefficients that are exactly the same. I don't have that. So now I want to check, can I multiply one equation and get coefficients that are the opposite? And I can. If I multiply my top equation by -4, then my s's would be opposites, and I could add them together and eliminate the s's. And my second equation stays the same. Add these together. -4a plus 8a is 4a. -4s plus 4s, 0, that's eliminated. -1,400 plus 2,000 would be 600. Divide both sides by 4. And we get A equals 150. If I take that and plug into one of my two equations, I can figure out my value for S, and I'm going to plug into the first one. So I get 150 plus S equals 350. Subtract 150, S equals 200. All right. Finish off by kind of labeling my answer. So 150 adults and 200 students attended the play. All right. Questions? Next example. Find two numbers such that their sum is 25 and their difference is 1. So circling all of the numbers. That 2 is a number. Have to circle it. Underline the question. It's kind of actually right here at the beginning. The question is, what are my two numbers? Box any keywords. So now we're going to test your mathematical knowledge here in just a minute. Write our equation. So my variables in this case, I'm just looking for two numbers. So I might just use X and Y. All right. It says their sum is 25. So what do I do with two numbers to find their sum? Yeah, exactly. Good, good. Sum means we're going to add. So we're going to take X plus Y, and that's going to be 25. And what does difference mean? Yep, exactly. Difference means we're going to subtract. So our other equation, X minus Y, and that's going to equal 1. Now, which method do you think we could use in order to solve this system? All right, all right. Yep, this one looks like elimination will set up pretty easy because I already have opposites for my y's. So I'm going to add these two equations. X plus X is 2X. Y plus negative Y is 0. 25 plus 1 is 26. Divide both sides by 2. Excuse me. And now plug that 13 into one of the two equations. Again, it doesn't matter which one. I'm going to choose the top one. And I'm guessing some of you maybe knew the answer before we did any of the math. It's just kind of nice to verify that the answer is correct. And again, I haven't checked any of my answers throughout this process. You certainly could. If I look at 13 plus 12 is 25, yes, good. 13 minus 12 is 1, yes, so I know that those two are correct. And now I can say the numbers are, and I always write my numbers lowest and then biggest. The numbers are 12 and 13. It's just a personal preference of mine. Right. So in this case, we had the two variables, we added them to get a value, and we subtracted them to get another value, and it really worked well for elimination. All right, here is another example, another situation. Traveling with the current, a boat went 20 kilometers per hour. Against the same current, it only went 4 kilometers per hour. What is the speed of the current? How fast would the boat go if there were no current? So again, start by circling our numbers. Underlining the question. So in this case, there are actually two questions. Box any keywords. And you could include traveling with the current. That would be excellent. Write our equations. Okay. So this example actually is the exact same as the previous example, except here we're talking about a boat and a current, and the previous one we were just talking about two numbers. So I am going to use my equation or my variables. B is the speed of the boat. C is the speed of the current. When a boat travels with the current pushes the boat. So the total speed is the speed of the boat plus the speed of the current to get my total speed. When we go against the current, the boat has to overcome the speed of the current. And so we get that B minus C equals 4. So if the boat was traveling slower than the current, the boat would actually move backward, is the idea here. All right, now we want to solve. Which method should I use to solve this system? Yeah, all right. And so are we getting the idea that with these systems, for word problems, elimination almost always is going to be the method that we use? I already have opposites. So like half of the problem is done. I just need to add B plus B is 2B. And if you're Shakespeare, maybe you'd want that to be not 2B, I'm not sure. C plus negative C is 0, it's eliminated. 20 plus 4 is 24. Divide both sides by 2. B equals 12. Take 12, plug it in to find C. 12 plus C is 20. Subtract 12 from both sides. And now label our answers. The boat travels at 12 kilometers per hour. The current is 8 kilometers per hour. All right. So the time has come for you to give it a try. And what I'm going to do is I'll just give you a few minutes. Go ahead and try each of these problems. And what I will do is, as the time is going, I will kind of add parts to the solution of the problem. So, excuse me. As you're working, I will mark up the problem and write the equations. And when the time is up, I'll show my solutions. If you have questions, please use the chat. That would be awesome. If you don't have questions, that's fine as well. And I'm going to start the time and mute myself and turn off my video. And actually, I'm going to go with 4 minutes. 4 minutes should be good. right, so what I got was each van has 9 students and each bus has 26 students. All right. Last example. All right, same thing. I am going to start the clock, mute myself. I will go through and mark up the problem, define the variables, write the equations at various times throughout, and then we'll come back and get the solutions. All right. Again, for this one, I got 85 students and 70 adults. Would help if I could spell correctly. Adults attended the game. All right, questions?